Hi, I'm Darren Starnes. In this video, I'd like to talk with you about using the 6th edition of the Practice of Statistics with the College Board's new course and exam description for AP Statistics. In February 2019, the College Board announced a new course framework for AP Statistics. This was the first major change in our course since it was launched in the 1996-97 school year. As part of that announcement, College Board released a new course and exam description, or CED, that outlines the required content and skills and defines how the content will be assessed on the AP exam. The course framework is organized into 9 units, each of which has an associated pre-prepared personal progress check that students can take as a formative assessment. Beginning with the 2020 AP exam, the free response questions will be defined by the skills they are assessing. We'll discuss the course skills a little later. Note that the weighting, timing, and number of questions on the AP Statistics exam will not change. However, there is a new formula sheet, which most of us are very glad to see. Another resource provided by College Board is an AP question bank with released exam items from prior years and additional personal progress check items that have been written for the 9 units. All of these items are searchable and filterable using the Understanding by Design structure of the new course framework. Now, as you're thinking about using TPS 6 with the new course framework, here are a few questions to ask. First, are you satisfied with your students' AP scores? Okay, let's be honest, none of us is ever completely satisfied, I hope. But are you generally satisfied with the pattern of performance from your students over several years? Second, are you confident in and comfortable with your current pacing and order of presentation? You'll see why I asked this in a moment. Finally, how do you plan to use the College Board's new personal progress checks? This is important because they're aligned to the units within the course framework. The good news is that the Practice of Statistics includes the essential content and skills that are included in the new AP Statistics course framework. College Board has indicated that you'll have the flexibility to organize the course content as you like, but there's a caveat. The AP question bank and the personal progress checks are developed to be aligned to the new unit structure in the course framework. So you need to think carefully about how you're going to deal with that new unit structure. Let's talk a little bit more about how the units are organized. So in the College Board structure, Unit 1, Exploring One Variable Data, is directly linked to Chapters 1 and 2 in TPS 6. Unit 2 on Exploring Two Variable Data is linked to Chapter 3 plus Section 12.2 on Transforming to Achieve Linearity. Unit 3 on Collecting Data matches nicely with TPS 6 Chapter 4. This very large Unit 4 on Probability, Random Variables, and Probability Distributions matches fairly well with Chapters 5 and 6 in TPS 6. Unit 5 on Sampling Distributions corresponds to Chapter 7 plus small subsections of 10.1 and 10.2 in TPS 6. Here's where the big changes occur. You'll notice that the College Board course framework organizes inference based on the type of data we're doing inference about, so categorical data or quantitative data. In the previous topic outline, we decided to organize based on the type of inference, that is, confidence intervals or tests. So that's how TPS is organized. So in the new structure, Unit 6 on Inference for Categorical Data Proportions corresponds to Sections 8.1, 8.2, 9.1, 9.2, and 10.1 in TPS 6. And Inference for Quantitative Data Means would be Sections 8.3, 9.3, 10.2, and 10.3 in TPS 6. Inference for Categorical Data Chi-square corresponds to Chapter 11 in TPS 6th edition, and Inference for Quantitative Data Slopes corresponds to just Section 12.1 of TPS 6. We have a more detailed alignment document with the new course framework that includes our recommendations about specific sequencing of topics and also about use of the personal progress checks. So this will be available to all TPS 6 users. Let's drill down more specifically unit by unit. This is Unit 1, Exploring One Variable Data. In the course framework, they introduce a new graph type, a mosaic plot, which is effectively a segmented bar graph for comparing groups where the widths of the bars are proportional to the size of the groups. So the widths of the bars in a mosaic plot are not equal like they would be in a segmented bar graph. Key terms to emphasize within this unit, within Chapter 1 of TPS 6, the discrete versus continuous variable distinction, which we've saved until random variables in TPS 6, is now part of the course framework. So for quantitative variables, a discrete quantitative variable is one that's involving counting, and a continuous quantitative variable is one that's involving measuring. Be sure to point out the distinction between descriptive statistics, where you're only focused on the data in the sample, and inferential statistics, where you're going from the sample to the population, or at least beyond the sample in an experimental setting. The introduction for Chapter 1 is a good place to do this. Go ahead and distinguish statistic versus parameter, as the course framework does, maybe when you're mentioning mu versus x bar, or Sx versus sigma x. When describing the shape of distributions, the course framework uses key terms unimodal and bimodal, so single-peaked and double-peaked, and approximately uniform. Also, make sure students know the distinction between the variance of a sample or population and the standard deviation of the sample or population. That's the square root of the variance. Within Chapter 2, we include describing location in a distribution, and also using normal distributions to model specific sets of quantitative data. So within the course framework, be sure to note that percentile is defined as the percent of observations less than or equal to a given value, and also that the course framework uses the term empirical rule as opposed to 68, 95, 99.7 rule. For the pacing of this set of chapters, follow our suggestions: 9 days for Chapter 1 and 7 days for Chapter 2, based on the teacher's edition. You're safe using Personal Progress Check 1 with your students after they complete Chapters 1 and 2 of TPS 6. Unit 2 on Exploring Two Variable Data. One note, TPS has always covered bivariate categorical data or two variable categorical data in Section 1.1, so that we add a little more meat to this fairly familiar section to students. Also, Chapter 3, Describing Relationships, gets augmented by Section 2.2 on Transforming to Achieve Linearity in the course framework. Be sure to mention univariate and bivariate for one variable and two variable data. And the course framework describes unusual points in a different way with scatter plots and regression. The idea of a high leverage point is one that's far out in the x direction from the mean of the x values. An outlier is defined as a point with a large residual, and influential points are ones that have a noticeable effect on things like the correlation, or r squared, or the standard deviation of residuals, or the slope or y-intercept of the regression line. Also note that the course framework has returned to the simple formula for a regression line that's used by the calculators, y hat equals a plus bx. Also ensure that you move Section 12.2 forward as a third section in Chapter 3. For pacing, 8 days for Chapter 3 and an additional 2 days for the Transforming to Achieve Linearity. You can use Personal Progress Check 2 at the end of Chapter 3 as modified. Unit 3 on collecting data matches very nicely with Chapter 4 in TPS 6. Be sure to mention systematic random sampling, where you have a random starting point within a group, and then you continue at every so many after that. Homogeneous, that is similar within, and heterogeneous, which is diverse within, are mentioned as terms within the course framework when we're talking about sampling. Also, the course framework distinguishes two types of observational study: prospective, where we're looking forward in time as the researchers, versus retrospective, where we're looking at already existing data. The pacing for Chapter 4 is as suggested in the teacher's edition, 11 days. Personal progress check 3 can be used right at the end of chapter 4. This large unit 4 on probability, random variables, and probability distributions includes both chapters 5 and 6 in TPS 6. So within chapter 5 on probability, be sure to emphasize the idea of a random process. We say chance process in TPS 6, and that one repetition of that random process is a trial. The course framework mentions empirical probability, where you actually toss a coin to figure out how often it lands heads, as compared to simulated probability, where you would perhaps use a random number generator to determine heads or tails based on a theoretical model. Use both disjoint and mutually exclusive when you're describing events of that type, because the course framework uses both terms. And mention a joint probability is the probability of A and B happening, another term in the course framework. In the chapter on random variables, be sure to mention the idea that a probability distribution for a random variable can be used to model a population distribution of a quantitative variable. And therefore, a parameter of a probability distribution, like the mean or standard deviation, can be used to represent the mean and standard deviation of a population distribution. A cumulative probability distribution, like binom CDF, helps you figure out the probability of getting a value less than or equal to a specified number. Be sure to distinguish a linear transformation of a random variable, like a plus bx, and its effect on the shape, center, and variability of the probability distribution, with a linear combination of two or more random variables, where we're multiplying by a constant and then adding or subtracting. We particularly are interested in linear combinations of independent normal random variables in this course. Also, the course framework begins its emphasis on the 10% condition and its connection to independent observations in this chapter or unit. And the course framework adds all aspects of a geometric distribution, the shape, center, and variability, which matches what it does for the binomial distribution in the previous topic outline. So for the pacing, same as TPS 6 suggests, 8 days for chapter 5, 9 days for chapter 6 in our 110-day pacing guide. You can use personal progress check 4 at the end of chapter 6. Unit 5 on sampling distributions. One note, TPS covers continuous random variables as part of chapter 6, which fits nicely with the random variables theme. But because of the length of unit 4, College Board has decided to roll this topic into its unit on sampling distributions. Otherwise, chapter 7 on sampling distributions plus, you need to add the subsection from section 10.1, the sampling distribution of a difference between two proportions with the corresponding exercises. Here are the page numbers. And at the end of section 7.3 in TPS 6, you need to add section 10.2's the sampling distribution of a difference between two means subsection with the corresponding exercises. So to repeat, section 10.1 goes at the end of the existing section 7.2 in TPS 6, and section 10.2 goes at the end of the existing section 7.3. Some key terms to emphasize from the course framework: point estimator. This is a value like x bar, p hat, x bar 1 minus x bar 2 that helps us get our point estimate, and later an interval estimate. Randomization distribution in the course framework is used to mean any simulated distribution of a statistic. We prefer to use this terminology for the simulated distribution of statistics obtained in experimental studies, but you need to be aware of the course framework's usage. And here the course framework goes deeper with the 10% condition and how that relates to the standard deviation of the sampling distribution of p hat or x bar. And it makes the point that the formulas we use are actually only correct if we sample with replacement, and that if you sample more than 10% of the population, which is not a bad thing because you're going to get hopefully a more accurate estimate, certainly a more precise estimate of the true population parameter if you use a larger sample that's random. The point is that the standard deviation formula we use is just too incorrect. We really should use a correction formula, finite population correction. But the standard deviation we calculate is too large based on our formulas. Also, The idea of independent observations, which is related to the 10% condition, is contrasted with independent samples. We need independent samples when we're doing the sampling distribution of a difference between two proportions or two means so that we can combine their variances so that we can treat those random variables as independent. So you'll need to add 2 days here to cover the new content on sampling distributions of the differences in proportions and means, which brings our recommendation up to 9 days. You can use Personal Progress Check 5 at the completion of Chapter 7 as modified. Now here's where things really take a turn because of the inference structure in the new course framework. So our advice is to teach Chapters 8, 9, and 10 in order in TPS 6 and then assign the progress checks as described below. This grid again summarizes how Units 6 and 7 look relative to the chapter structure in TPS 6. So use the Unit 6 assessment after Section 10.1 on comparing two proportions. That completes all the proportions material. And then use the Unit 7 personal progress check after Section 10.3, which completes the material on means. We'll now drill down chapter by chapter within TPS 6, within Units 6 and 7. So we're talking about inference for categorical data proportions or inference for quantitative data means here. Within the Chapter 8 on confidence intervals, be sure to emphasize that a confidence interval is an interval estimate of the plausible values for a parameter based on the sample data. The course framework makes this point in several places. Also, that a confidence level is the long-run capture rate of the method when conditions are met. So if we take many, many random samples of the same size and the conditions are met, then the capture rate in the long run should match well with the confidence level. Also, the course framework has decided to emphasize two primary purposes when checking conditions. One is verification of independence, in this case with one sample, that the observations in the sample are independent of one another. And the second is that the sampling distribution that underlies our inference is approximately normal. Fortunately, the same three conditions that we've been checking in TPS are still applicable. The random data production, in this case random sampling, 10% condition when sampling without replacement. Those two are both critical for ensuring that the observations in the sample are at least approximately independent. And then to check that the sampling distribution is approximately normal, we use the large counts conditions for proportions. So we look at n times p hat and n times 1 minus p hat before we construct our confidence interval and make sure those are both at least 10. And when doing inference about a mean, we check the normal large sample condition. So either the population is approximately normally distributed or the sample size is large enough. So say n is at least 30. One comment here, when we do inference about a mean, we actually use a t-distribution when sigma is unknown. But the t-distribution assumes a normal population distribution or a large sample size so that the underlying sampling distribution of x bar is approximately normal. Some students get confused about this normality of the underlying sampling distribution still being critical in AP statistics to the use of a t-distribution for inference about means when sigma is unknown. The course framework has changed the formula slightly to statistic plus or minus critical value times standard error of statistic. So be sure that students are comfortable with that. Also, when you're doing inference about categorical data for proportions, point out that you can use a confidence interval for a proportion to get a confidence interval for, say, a total, as has been done in a couple of previous exam questions. And help students understand that confidence intervals for a proportion or a mean, the relationship between the sample size and margin of error is that the margin of error is proportional to 1 over the square root of the sample size. So this helps them get an idea of how the two are related, sample size and margin of error. Again, we recommend staying in order chapters 8, 9, and 10 in TPS and following the pacing guide there. For chapter 9, testing a claim, once again, we've mentioned the purposes for checking our random 10% and large counts or normal large sample condition for testing a claim about a proportion or a mean are so that the observations within the sample are independent or at least close and that the sampling distribution is approximately normal. The course framework has made a small change again in the formula for the standardized test statistic so that it's statistic minus parameter over standard error of statistic. We like the parenthetical because it really is the standard deviation as of the statistic as calculated if the null value is true in some cases. So we hedge our bets with the parenthetical. As with the confidence level, you should point out to students that the p-value is the probability of getting evidence for HA as strong or stronger than the observed evidence when HO is true and the conditions are met. So that means that the probability model that underlies it is true as well. Within Chapter 10, comparing two populations or treatments, this completes the Unit 6 and 7 in the College Board's structure for inference about means or proportions. We have conditions slightly different now because of the two samples or two groups in an experiment. So we have independence of samples when we're sampling, and independence of observations within each sample is still a requirement. And then we need the sampling distribution that we're using to be approximately normal. So we check the same three conditions. Randomness in this case means independent random samples, or if we're in an experimental setting, random assignment to treatment groups. We check the 10% condition only if we're sampling. And when we're checking the large counts condition for proportions and doing a test of HO P1 minus P2 equals 0, that is, assuming that the population proportions are the same, we check the large counts condition using the combined or pooled proportion of successes p hat combined. So you add the successes in the two samples together and divide by the total sample size, multiply that value times the sample sizes n times p hat combined and n times 1 minus p hat combined for each sample. The randomization distribution that one gets when doing an experiment for a difference in proportions and means is well modeled by the sampling distribution if the conditions are met. So this is something the course framework and TPS 6 both point out. Our other strong recommendation based on the course framework is to use the degrees of freedom from technology when doing the two sample T intervals or tests. The approach that many of us learned back in the 1900s of using the more conservative DF of the smaller of the two individual DFs from the sample size minus 1 is starting to be viewed as obsolete. It's still used in some places, but technology gives you more precise estimates using this larger DF from the technology. Again, you can use Personal Progress Check 6 after Section 10.1 and the Personal Progress Check 7 after Section 10.3, which involves paired data in TPS 6. Unit 8, Inference for Categorical Data chi-square, is coming up next. One thing to consider, this is nearing the end of the course, you might want to combine Chapter 11 with the new shorter Section 12.1, which just involves inference about slope, just for your efficiency. So in Chapter 11, Inference for Distributions of Categorical Data, remind students that the chi-square statistic measures how far the observed counts are from the expected counts relative to the expected counts. It's that last part that they sometimes forget. The conditions for chi-square tests, the purposes look similar. Independence of observations for sure, maybe also independence of samples, and that the sampling distribution is approximately chi-square, not normal, chi-square. And our three checks are the same: the random condition, random sampling or random assignment, 10% when sampling, and then the large counts here is that all the expected counts are at least 5. Students often like to think it's the observed counts. This is a good place to emphasize the p-value interpretation. Students need practice interpreting the probability in a context with chi-square, and so this is a really good place to do that. Pacing, we recommend the 6 days suggested in the TPS Teachers Edition. You can use Personal Progress Check 8 at the end of Chapter 11. And finally, Unit 9 in the College Board's Course Framework, Inference for Quantitative Data Slopes. A couple of notes about Section 12.1 and TPS 6. The sample or estimated regression line notation in the course framework is the simpler y hat equals a plus bx, and the population or true regression line is given by mu sub y equals alpha plus beta x. Unfortunately, now alpha could represent the probability of a type 1 error, i.e. the significance level, or it could represent the y-intercept of a linear regression model. One other note in the condition checking for inference about linear regression, the course framework has included a sample size override for the normal condition. So the usual condition for the linear regression model is that for each x value, the distribution of y values is approximately normal. And the sample size override allows for n being at least 30 to offset the necessity of the normal distribution of y values at each x. We recommend about 3 days for this section, and aka unit in the College Board framework. You can use Personal Progress Check 9 at the end of section 12.1. I mentioned earlier the course skills. This is the course skills matrix that the College Board has put together. You'll see that there are 4 skills emphasized that are meant to be spiraled throughout the course. Selecting statistical methods, data analysis, using probability and simulation, and statistical argumentation. I think we can all agree that practicing statisticians would need to invoke each of these skills effectively in order to do their job successfully. You'll see within selecting statistical methods that TPS 6 uses that skill in chapters 1 through 12 for 1A and 1B. For gathering data, that would be chapter 4. Representing data occurs in chapters 1, 2, 3, and section 12.2. So that's how the specific skills are mapped to the chapters and sections within TPS 6. Now, if you're wondering what happened to inference, fear not. There is a bottom half of the skill matrix that's dedicated to inference. And you'll notice that there are no skills attached to the data analysis category within inference, because data analysis is exploratory and descriptive statistics. But for the other skills, selecting statistical methods, using probability and simulation, and statistical argumentation, there are several skills within inference. So the skill categories will be assessed on both sections of the AP exam. On the multiple choice section, the questions are weighted by skill category, these 4 skill categories. And the free response questions are tagged or specified by skill category. Also, the AP question bank that's provided and the personal progress check items will be tagged by skills. So it's important that students continue to use these skills regularly throughout the course, and if you use the personal progress checks that College Board has prepared, that'll occur naturally. If you're pulling from the AP question bank, you'll want to be sure that you're thinking about all 4 of the skills throughout the course. So again, the order of the new course framework is different, but the practice of statistics includes the content and skills that are required for student success on the new AP Statistics exam. We have prepared printed versions of the updated alignments, the new pacing guide, and a few handouts specific to topics like mosaic plots and systematic random sampling on this site. So, unfortunately, with timing, the College Board announced the new course framework just the year after we had finished the 6th edition. So if we had known a year sooner, that would have been ideal, but that's the way it is. So what we've had to do, we felt we had to do, was prepare an updated version of TPS 6 that aligns very closely with the new course framework. So this document shows that the soon-to-be released in July of 2019 preliminary volume of the updated TPS 6E will align very, very closely. And you can see that we've reorganized the inference chapters in TPS 6E updated. Chapter 8, Estimating Proportions with Confidence, and Chapter 9, Testing Claims About Proportions, are now covering Unit 6, Inference for Categorical Data Proportions. Chapters 10 and 11, Estimating Means with Confidence, Testing Claims About Means, take care of Unit 7 in the course framework, Inference for Quantitative Data Means. And we've combined Units 8 and 9 in the course framework in the new Chapter 10, Inference for Distributions and Relationships, that covers chi-square and inference about regression slope. So in our case, we purchased the 6th edition a year ago for our students, but we really want to be able to use the new personal progress checks and the AP question bank as intended. So we've made the decision to roll to the updated version of TPS 6E with the preliminary paperback version this summer and then our students will get the hardbound version in January of 2020. It's for our viewpoint, if it's something that you might be able to do at this point, if you think you can do the funding and get an adoption or a switch of additions to the updated edition, I encourage you to talk to your BFW rep. They're very sensitive to the fact that all of us have just recently purchased the 6th edition new, and they want to try to work with folks who have the opportunity to roll to the updated version to make their students' lives and their lives a lot easier with the structure of the new course framework. So again, I encourage you to talk to your BFW rep with any questions. Here's the website that's live for the updated TPS 6E. And on behalf of Josh Tabor and myself, I want to thank you for using the practice of statistics for your AP course, and I want to wish you continued success with your students. Thank you.